Hello everyone, welcome to Compiler Design video series. In our previous video, we have already discussed about how to convert given regular expression into NFA, then convert it into DFA using Thompson's rule. Today we discuss about another example, which is A, B star, A or B. First, draw NFA for the given regular expression. First input is A, so start with initial state 0, then input is A, next state is 1. Then draw NFA for B star. So first epsilon, then B, loop back with epsilon, next state epsilon. If there is 0 occurrence, then from 1 to 4 epsilon. Now join NFA of A or B. Next state 7, 8, input is B, epsilon, 9, which is your final state, so indicate by double circle. Input epsilon. This is also known as epsilon NFA. NFA for A, B star, A or B. So first you have to draw NFA using Thompson's rules of given regular expression. Then find epsilon closure. So first start with initial state epsilon closure of 0. Epsilon closure means find epsilon transition from given input. Here your input is 0. So find epsilon transition from state 0, which is nothing. So 0 itself give the state A. Then find move A to A. A is 0, then find 0 to any A transition is given. Yes, 0 to A, we reach at state 1. So move A to A is equal to 1. Next find epsilon closure of move A to A. So find epsilon transition from 1. First write 1 itself, then any epsilon transition from 1? Yes, there is 2. From 2 any epsilon transition? No. From 1 any other? Yes, 4. Whenever you reach at 4, you have any other epsilon transition? Yes, it's 5 and 7. So epsilon closure of move A to A equal to 1, 2, 4, 5, 7. which is new state. So indicate it by B. Now find move A to B. Your A state is 0. So find from state 0 to any B transition. No, there is nothing. If any string is start with B, then it is at dead state, which is empty state, indicated like 5. So epsilon closure of move A to B is equal to 5. You can write 5 as it is or give a state name to 5. So next your state is C. Here I indicate 5 as a state C. It's not compulsory to give empty state as a name. You can directly use 5 as a state. If your any string is start with B, then for this grammar it reach at dead state. Now find move B to A. Your B state is 1, 2, 4, 5 and 7. So find from 1, 2, 4, 5, 7 any A transition is occurred, any A input is occurred. Yes. From 5 there is A transition. Five to A you reach at 6. So move B to A is equal to 6. Now find epsilon closure of move B to A. So find epsilon transition from node 6. So 6 itself, and from 6 any epsilon transition? Yes, which is 9. So 6 and 9. Both are included in epsilon closure of move B to A. Here 9 is your final state in NFA. So this state is indicated by D. So in DFA your D state is a final state because 9 is included in the epsilon closure, which state is indicated by D. So D is also a final state in DFA. Next find move B to B. From B state there is any B transition is occurred from 1, 2, 4, 5, 7. Any B transition is occurred? Yes. From 2 to B transition, so it is 3, and from 7 to B transition, which is 8. 7 to B, which is 8. So move B to B equal to 3 and 8. Now find epsilon closure of move B to B. So find epsilon closure from 3 and 8. First 3 and 8 include itself. Then check from 3 there is any epsilon move. Yes, there are 2 epsilon moves. One from 3 to 4 and another from 3 to 2. So 2, 3, 4 also include in epsilon closure of move B to B. From 4 there is any epsilon move. Yes, 4 to 5 and 4 to 7. So 2, 3, 4, 5, 7, 8 and 9. From state 3 there are 2 epsilon moves, one from 4 and one from 2. So 2, 3, 4 included. From 4 state there is another 2 epsilon moves, 5 and 7, which is included. 2, 3, 4, 5, 7. 8 itself included. Then from 8 any epsilon moves? Yes, it's 9. So 2, 3, 4, 5, 7, 8, 9. Here 9 is your final state in NFA. So in DFA, E state is also a final state. So not that, here 2 final states are there. One is D and another is E. Now move C to A. Your C is dead state or empty state. So move C to A is equal to 5. Then epsilon closure of move C to A is also 5, which is indicated by C. So move C to A is equal to 5 and epsilon closure of move C to A equal to 5, which is C. Next find move C to B. It's also 5. So next epsilon closure of move C to B equal to 5, which is C. Now you have to find move D to A. Your D state elements are 6 and 9. From 6 to 6 and 9 there is no any input symbol move. So move D to A is equal to 5 and move D to B also 5. Move D to A is equal to 5. Epsilon closure move D to A. It's also 5, which is indicated by state C. Next, find move D to B. Your D state to B input, there is nothing, so move D to B equal to 5. Epsilon closure of move D to B is equal to 5, which is indicated by C. Next, move E to A. Find input transition for A from state E. That is 6. So we have already found epsilon closure of 6. So epsilon closure of move E to A is equal to 6 and 9, which is state D. Next, find move E to B. Find input transition from E to input symbol B, which is 3 and 8. We have already found epsilon closure of 3 and 8. So epsilon closure move E to B is equal to 2, 3, 4, 5, 6, 7, 8, 9, which is your state E. So now no any other states, so we can draw state transition table. Here for state transition table, vertically you have to write input symbols and horizontally you can write total number of states which you derived. In this example we derived, there are 5 states, which is A, B, C, D, E, and there are 2 input symbols A and B. So write down total number of state and input symbol. Input symbols are A and B. Now you have to write in transition table. So first check what is the state when you move from A to A. A to A you got state B and move A to B. You got state C. So write this entry in transition table. From state A, input state is A, then next state is B. State A, input B, then next state is C. Now check for next move B to A. B to A, next state is D, and B to B, next state is E. So write this entry in transition table. B to A, D, and B to B, E. Now check for C state. Move C to A. Move C to A, C, and move C to B. It's also a C. So entry for transition table: C to A, C, and C to B, C. Now for move D to A. So D to A, it's also a C state. And D to B, it's also a C state. So write this entry in transition table: D to A, C, D to B, C. Now check for E state. Move E to A. Move E to A, next state is D, and E to B, state is E. So E to A, D, and E to B, E. This is your transition table for A, B star, A or B. Here in NFA, 9 is your final state. So in which state you got 9? In state D and state E, you got the 9 state. So in DFA, state D and E, both these states are final states. So now draw DFA from your transition table. First, you can draw state in any order. It's not compulsory like you have to draw these all states position are like here. You can draw it in any order. A inputs A, then your next state is B. A input B, then state is C. B input A, then state is D. B input B, then state is E. Here D and E both are final states, which is indicated by double circle. Now C to A, C, and C to B, C. So it is not necessary to draw 2 times arc. In single arc, you can write input symbol separated by comma. Now from D state, input is A, then reach at state C. D to C, input is A. Now D to B, then reach at state C, so write it by separating comma. Now from state E, input is A, then reach at state D. E to D, input is A. Now E to input is B, then reach at E. So self loop, input B. So this is your DFA for A, B star, A or B. DFA for A, B star, A or B. And this table is your transition table for A, B star, A or B. It's also known as state transition table and state transition diagram also. State transition table for A, B star, A or B. So according to DFA or given any regular expression, you can use any string for check your DFA is true or not. For example, for this I can write any string like A, B, A, then it's a valid or not. According to DFA, there is 0 or more occurrences of B start with A and end with A, which is valid and reach at final state. So it's a valid string. Now check for any other string which is start with B. Any string which starts with B, it's not a valid string. B, A, then it does not reach at any end state in FA. So it is not a valid string. It means BA is not recognized by this DFA because it starts with B and our expression is A, B star, A or B. It means any expression start with A. So BA is not a valid string. Next string is A, B, B, B. Then check for this string is valid or not. It's A, B, then any occurrences of B, it's valid. So A, B, 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 it's a valid string. Because it starts with A, there are 2 occurrences from B star and it's end with B. Next A, B, B, A. Start with A, 2 occurrences of B and end with A. Then it's also reach at final state. So it's also a valid string. So these all are example of strings which is recognized by A, B star, A or B finite automata. So now you can check for any example or any other string. For example, I can write A, then it's a valid or not. Yes, it's a valid because 0 occurrences of B star. Then start with A and end with A. So it's a valid string which is accepted by finite automata. So in this example, we see that how to convert NFA into DFA.